It's okay. I'll reminding so no problem. Just I'm pointing only few points only I'm repeating, right? So what is a modem? Simply to understand, from your home, you want to connect it to internet. What we need is a modem. Okay, what we need is a modem. So through the modem, we can able to connect it to ISP. So you have a Geo internet, or maybe you have a Airtel internet, ACT internet. So there is a cable is connected to your Wi-Fi router, and where this cable will goes to some junction from that one, then again, finally it is go to ISP only. So what is ISP? Internet Service Provider. So if first of all you have to reach up to ISP, and then in ISP you will verify your username and password. Is this a subscriber having a 30 Mbps connectivity? Is this user check the username and password, authenticate, and this user having a 100 Mbps connectivity, this user having a 40 Mbps connectivity. So what this ISP is doing? So once they are verify your identity, so then based on your subscription, he is allowing to access the internet with what speed you are subscribed, right? So this is happened at ISP.
Okay, thank you, sir.
Okay, very good. So to reach internet, to access internet, and we have to access internet, we have to reach ISP. To reach ISP, we are connecting modem to ISP. Okay, so these are all we are discussed. Some are main points, but what we have done, we skipped a lot of things. We didn't record those things. Okay. Anyway, I'm not repeating again, but there is this point. Here it is. My favorite point is there called SOHO. Small office, home office. What is this small office, home office kind of stuff? We'll see one point and I will make it another point. So this is may not be seen. Okay. So second point you're definitely seen. That's the point here it is. Guys, look at here. In generally, you want to connect a device in the LAN. So what we need a devices, and we have to connect the devices to hub or a switch. So that is simply a LAN, a private network. It is. For example, you have a wireless devices. You have a laptops, mobile phones are there. You want to connect those devices together and make them communicate each other. So we need a wireless access point. If you connect your wireless devices to wireless access point, that type of connectivity is called WLAN, wireless LAN. What is WLAN? Wireless LAN. LAN, wireless LAN. Okay. Next. Of course, you have a LAN or WLAN is there. Now you want to communicate outside of your network. Outside of your network, internet or anything, outside of your network, you want to communicate. You have to communicate through router. What is a router? Inter-networking device. It make a communication between one network to another network. Okay. It made a communication between two or more networks together. So it means in here we are using our LAN. We want to communicate outside of our network. Okay. So, but you want to communicate outside of your network, you have to connect it to internet, right? To connect to internet, what we need a modem. So what is this modem device is doing? We are connecting to ISP, so then you can connect it to internet using a telephone cable or fiber optical cable. Who is ISP? Internet Service Provider. So once you are connected to ISP, we are getting internet. So you may get a doubt, sir, in my home, I do not have any hub or switches to connect my desktop or laptop. I do not have any Wi-Fi access point to connect my mobile phone or laptops kind of stuff, right? So I do not use any routers and modems in my home to connect internet, but I am getting internet with a simple Wi-Fi router. Yes, because our home Wi-Fi router has built-in kind of stuff is there. Is what are the built-in inside is modems routers, wireless access point, hub RS, switch kind of stuff. If you take a Wi-Fi router, original pure Wi-Fi router does not have anything, but in our home we have a mixed kind of stuff is there. So you can see we need a backside kind of stuff. Little costlier. Anything, no problem. See, this is a Wi-Fi router, right? This is what we are saying. It is dual band, wireless, cable router, Wi-Fi speed, something it is given. You see the backside. So what it is saying, there's a charger, and this is the blue one is for WAN connector. Like you have ACT internet. So ACT internet will give directly the LAN type of cable. So there you can connect it to WAN. You have a desktop or a laptop, you want to connect with the wire, you will connect with this, the blue colored one. So that, sorry, yellow color one. Yellow is for a LAN connectors, right? So this is, so this WAN port for a modem connector, and this yellow is for desktop, laptop, LAN connector. Okay. You can DSL type of things are there. This is DSL. We'll try DSL. DSL is not showing this 300 kind of stuff. We need a D-Link DSL, ADSL, DSL, ADSL. Not. For example, you have a Wi-Fi router. Sorry, you have a internet connection. BSNL type of internet connection is there. BSNL type of internet connection is there. So instead of this LAN port, you will get a what we can say RJ11 connector you are getting. In case you have a Geo Wi-Fi router, so Wi-Fi router it is. So home connection type. This is air fiber, the new one it is came. That is also fiber optic cable, antenna is there. Not this one. So why it is the remote or what? Like this kind of stuff. Okay. So if you see, I missed something. Okay. LAN connectivity and fiber optical connectivity is also there. So from outside, you will get a fiber optical cable, which is going to the router. Okay. So this is some setup box kind of stuff. Okay. So internet, they change a lot of things one to another one. The earlier one is correct one. This is another type of box like this. It is coming, right? So if you go to this, the backside one, don't point that. Okay. So one side is like a fiber optical cable from outside to inside, and you want to connect it to your laptop or desktop, you will get a LAN ports you are getting and Wi-Fi also there. So it means one box of this one, and the earlier one also showed now. So what it is, it contains a modem to connect your ISP for internet purpose. It is a router from outside, from your ISP to you, you are getting internet, that is different network. But inside you have a different network. What is this router is doing? It will make a communication between this outside network to inside network. That is a router. Wireless access point. You want to connect to the network wirelessly. What we need a wireless access point. You want to connect as a LAN wide network, you need a hub and switches. So the router having all these kind of facilities in one only. And also it is act like a default gateway. What is a default gateway? When you want to communicate outside of your network, for example, I am in a room, I want to go outside of my room, I have to go to the door, right? That the gateway is there. So like that, this network, you want to communicate outside, so they have to go through the default gateway. So the router is act like a default gateway and DHCP server and DNS server also. Okay, to communicate in the network, so we need a connectivity, IP address, and protocols, of course. Okay, so your Wi-Fi router is act like all these things. Yeah, all are we discussed, but we leave those points aside. Uh, the last few more points are there about IP address and then some OS layers part. Okay. What is an IP address? IP address is a logical address, uniquely identify a device in the network. Every device must have an IP address to communicate in the network. Okay, every device must have an IP address to communicate in the network. And all communications are going with an IP address only. Guys, when someone is asked a question, what is an IP address? IP address is a logical address. MAC address is physical address. So IP address is a logical address. IP address is a uniquely identified device in the network is IP address. I have a 10 computers are there. I want to communicate to the 10 computers. One by one, I want to communicate. They need an address, right? I want to communicate it to you. So you should have a name. So then I can able to communicate it to you, right? So if I something tell me about what is MAC address, to whom I'm asking. If I ask to a person, so like Aishwarya is here, so ask Aishwarya what is an IP address. It means a unicast. Okay, uniquely identifying. Why we should have a name for identifying purpose, right? Like in network, devices should have an IP address for identification purpose. Devices should have an IP address for identification purpose. And IP addresses we can able to change, we can able to assign or configure manually, or we can assign or configure automatically by using DHCP server. These IP addresses are two versions, IPv4 and IPv6. If you are comparing difference between IPv4 and if you are want a difference between IP address and MAC address, again, MAC address is physical address, IP address is logical address. MAC address, you cannot change it because it is assigned by manufacturer of that NIC. IP addresses can be changeable either manually or automatically by DHCP server. Okay, we can change it as per our network requirement. In IP addresses, we have two versions, IPv4, IPv6. MAC addresses, only one version, that 248-bit, represented in hexadecimal. IPv4 and IPv6, two versions. IPv4 is 32-bit and IPv6 is 128-bit. IPv4 is represented in decimal format. IPv6 is represented in hexadecimal format. This is an example of how IPv4 is there, and this is an example of how IPv6 is there. IPv6 can be in a different forms, okay? So same form only, but you can write in different ways. And IPv6 is totally 8 blocks are there. In each block contains 4 hexadecimal numbers, and those 8 blocks are separated by colon. Again, coming to the IPv4, the entire 32-bit is divided into 4 parts. Each part we call it as a octet. Octet means 8 bits. It means each part is having 8 bits. So first part is called first octet, second octet, third octet, and fourth octet. Okay. The IP address range is from 0.0.0 to 255.255.255. IP address are divided into 5 classes. Class A, Class B, Class C, Class D, Class E. Each first class A is 0 to 127, means it's 1 to 126. Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, and Class E 242 to 55. Okay, and Class D and Class E we don't assign IP addresses to anyone because Class E is for some organization research purposes. Some places maybe they will use it, may not be used, not for any public purposes. Okay, general purposes. It's reserved IP addresses. And Class D is a multicast. It is used by certain protocols only, not by individual users. Not only that one, guys, the 0.0.0 is called unknown IP address. It is reserved for a certain protocols like DHCP, default routing kind of stuff. And entire 0 series we are not using. 127.0.0.1 is called a loopback address or localhost address, used for self-testing, self-system access purpose we are using. And one entire 127 series we are not using. Okay, so we cannot use class E and class D also. And we are using class A, class B, class C, except 0 series, 127 series, and one more series is also there. And these are all unicast addresses. What is unicast? To communicate in the network. So we are actually one-to-one communication we are doing. APC to BPC, DPC to EPC. Like that we are doing it. That is called unicast. Okay. How to recognize which class the IP address is related to. So based on their first octet, check their first octet of an IP address, compare with this table. So if it is in the range of this one, so we can understand. So for example, it is 134. It comes under class B, 156 class B, 10 is class A, 194 class C, 227 class D. Like that. And these IP addresses, again, it is 2 parts. What is network part and host part? Network portion and host portion. IP addresses are 2 parts are there. Network portion and host portions are there. What is this network and host portions? Why we should think like this? Okay, guys. Network portion, it means if there is a 10 computers, all the 10 computers having IP address, their network portion is same. It means these systems can communicate each other. They are in the same network. Their host portion must be different. Why? See like this. For example, I put a roll numbers like this. This is something roll numbers are there. See, first person roll number is 1, 2, 3, 4, 5. But remaining details are same. For example, batch 1. Sorry, batch 3, 4, 5 is then so batch 3. For example, batch 3 is there. Batch 3, roll number 1. Batch 3, roll number 2. Batch 3, roll number 3. Like that. It means the common one is batch. It is like a year belongs to this particular batch. Roll numbers are different. If you put the same number for both, it is conflict, right? Same thing. Batch 4, roll number 1, batch 4, roll number 2, batch 4, roll number 3. It means those three members are belongs to batch 4. So different batch it is. So how to define based on the portions. Same way we can define based on their portions. For class A, the first portion is network portion, remaining is post portion. It means you create a network in a class A. Their first portion must be same for a same network type. Means same network only communicate each other directly. Class B, first two portions are network portion, next two portions are host portions. It means the first two portions must be same in entire network. Class C, first three portions are network portions, the last portion is host portions. Means entire network, first three portions must be same. Okay, if you want to make a communication between the devices, their network portion must be same, host portion can be different. Okay, so that's the point here. Again, if you see there is a devices, check the network portion, one of the device network port different, so that device is not in their network, so they can't communicate. Okay, the entire host portion should not be same in the same network. At least one of the host portion must be same. It means if you see this entire, all three should not be same. One, at least one host portion is different, that is more than enough. You see, here it is, two places, host portion is different, good, no problem. If only one place, host portion is different, no problem. Okay, but all three places, like, sorry, all three places different, no problem. Depends upon host portion is either all host portions are different or at least one portion is different, okay. Okay, but all for host portions are same, that is a conflict, that is a conflict. So how system divided? Okay. Okay, guys, so keep it in always mind when you are writing a IP address. So then what IP address, which class of it, and what is their network portion and host portion. And you have a 10 systems, you are assigning an IP address to 10 systems manually. So what I have to keep in mind, network portion must be same for all systems, and host portion, at least one of the host portion is differ from another one. Okay, then only they will communicate. What is a subnet mask? Subnet mask divide an IP address into network and host portions. We can able to understand based on the class of IP address, which is network portion and host portion. How system will understand which IP address you are given and what is their network and host portions. Depends upon the subnet mask. The default subnet mask for a class C type of IP address is 255.0.0.0. If you observe where is the network portion is by default is there it is 255 is there. Class B 255.255.0.0, class C 255.255.255.0 by default subnet mask it is. Why it is called a default subnet mask? Because we can able to change it. But if you change it, the network and host portions are changes. So when you're doing it, please be careful. You must know how to calculate the network and host portions to do it. Okay. So how system will understand? System understand by end operations. So there is a logical end operation is there. So using that end operations, it calculate your network ID using your IP address and subnet mask. What system is doing? It calculates network ID from your IP address, system IP address, and subnet mask. If network ID is same for the devices, it will communicate. Like you want to ping to A to B. From A, it calculate the A's and B's network ID. So both network IDs are same, they can communicate each other. Otherwise, they can't communicate. Even though both systems are in same class, but the network ID must be same. Okay. Next, what is this slash notation? This is called a slash notation or CIDR method or prefix method. What is it? The slash notation represents the subnet mask. You want to write a subnet mask like 255.255.255.0, simply you can write /24. Or you want to write 255.255.240.0, you can simply write /20. Okay, what is this slash notation? So number of ones in the subnet mask. Just if you take /25, 25 ones, remaining is zeros. Like that only. Already you know, just I'm repeating. Okay. And coming to the IP address part, guys, there is Class A, Class B, Class C IP addresses. The ranges are there, Class A range, Class B range, Class C range. What is this private IP address? I have a LAN network. Within my private, I can communicate each other without purchasing any IP address. I no need to pay for use these range of IP addresses to communicate in private. I want to communicate in the public. I need a public IP address. I need a public IP address. So then I have to buy the public IP. I need to access internet. I want to communicate outside of my network, means public network I want to access. I need a public IP. But to communicate in the private network, you don't need to buy anything. You can use any of private IP address. Depends upon your network size. You can choose either class A or class B or class C. For example, I have 100 computers are there. I choose class C. Why? Because of number of hosts per class C is 254. Okay, in a class C, one single class C network, you can get up to 224 hosts we can able to connect. If you go to the class B, you can connect 65,534 devices in a one single logical network. If you take class A network, you can connect 16 million devices into one single network. So that's the point here it is. Okay, point is, so these IP addresses, the private IP addresses are non-routable in public. We cannot communicate in the public using private IP address. To communicate in the public, you need a public IP address. But I'm getting internet without configuring any public IP to me. How I'm getting? My ISP is taking care of it. Okay. So guys, for private to public communication, there is a techniques called a PAT and NAT type of techniques. What is NAT? Network Address Translation. What is NAT? Network Address Translation. What is a PAT? Port Address Translation. For example, I have a server in my network and assigned with a private IP. For example, 170.16.0.25. It is my server IP address. I'm in the same local network, okay, with the same kind of IP address like a 172.16.0.11. This is my client PC. So I can able to access my server one directly, okay, in the same physical network, same logical network also, because it's a private IP address, we can able to access. Someone in the internet want to access your server. How can they access? Go to the internet, search for your IP address. IP address never be found because it's a private IP. They cannot reach with your private IP. So what you have to do? Go to ISP. Okay. Go to ISP. Ask a public IP address for you. So they will give a public IP for you, and you are directly exposing to the internet. So you do not want it. So what you will do? How you are connecting? SP, modem, router, something is there now, like this. Okay. So what this doing it is, we use a technique called NAT technique. What is this NAT technique? Network address translation. The originally internally a private network, when this is S1 is communicating outside, when this S1 is communicating outside of our network, we are communicate with the public IP. For example, 20.4.3.2. Okay, so this is my public IP. Original is private IP. When I am communicating outside, it is a public IP. So this guy will access me with this public IP only. It does not know what is the internal private IP address. If he's sending packet to with this IP address, it goes up to ISP, it come to me. When I'm giving reply, that time again with this IP address only, I'm giving reply. Okay, that is called NAT, Network Address Translation. You have a private IP address and you have to purchase a public IP address for it. You have 10 servers, 10 public IP addresses, you have to purchase it. Okay. But in our home, how many people are using internet from one connection? Or everybody is buying a public IP address for it? It's difficult, right? So what we are doing is for all private, so we are doing this technique. Even we are not doing directly, but our routers, our ISPs are doing that technique. These are all private IP addresses only. Okay. When they are communicating, they use only one public IP address. They use only one public IP address. Everybody use one public IP, all communicating with a single public IP address only. So how it is possible? Port addresses. Port address. For example, see it is, this is a private IP, this is public. This is private, this is public. See the public address is same for all the three devices, but they are mapped with the different port numbers. So outside communication, we can do it. Of course, in internet, we are from the home, we are not accessing from internet. We are accessing to internet. We can able to access internet. You are accessing Google, you are accessing YouTube, you are accessing kind of stuff. You are not getting accessed by others. You are accessing others. Based on that only connectivity is coming, right? So what we are using is port address translation. Okay. So this is about NAT impact. So one more topic is left in the mainly in the networking, that is called OSI model. Then we'll take 5 minutes and complete this. Oh, 2 points are there. Guys, up to here, okay? The IP addresses, private IP addresses, classes, NAT impact.
Yes, sir.
So 2 points, just we'll take it and we'll take a break. So I will ask Ravan sir, if Ravan sir having afternoon classes for any batches, we'll discuss again on Monday. Otherwise, I will take afternoon. Okay. But put a message to Ravan sir. Is Ravan sir is taking any afternoon session for your batches? Okay, please.
Yeah. And batch two, not, will 3 and
Okay, we'll see the protocols and port numbers and voice model. What are the protocols? Protocols are set of rules. When we are communicating in the network, Communication means what? Email communication, file transferring related, right? Or streaming related, maybe remote access related, web pages related, web access related, right? So different types of communication is there through the network. Authentication related communication is there. Okay. So how the remote system will understand what is type of communication you want to do it, right? I want to send a mail. How my mail server understand you want a mail communication or just a ping communication or remote server access communication or just an authentication kind of communication. So how other system will understand what is your request, okay, based on the protocols. What is this protocol? Defines what type of communication it is. Servers and clients will understand these protocols so they can understand what type of communication it is. Okay, it defines what type of communication. For understanding the communication, understanding request and responses from devices. Okay, so for example, here it is HTTP protocol. What is the HTTP and HTTPS for? Web type of communication. Port number is 80 and 443 for HTTPS. What is the difference? HTTPS is secure, data is encrypted. HTTP data is not encrypted. So that's why your emails, most of the websites nowadays are HTTPS because the data is not manipulated or not stole by others, right? Your Gmail, Facebook, Google, all they're using HTTPS. So the data is end-to-end encryption. FTP, you want to upload or download a data, so you can use FTP protocol. SSH, Telnet, and RDP for remote access purpose. SSH having encryption, Telnet do not have encryption kind of stuff. SMTP, POP3, and IMAP version 4. These three for mail communication. SMTP for sending a mail purpose. Like I want to send a mail, so then I use SMTP. I want to retrieve a mail from the mail server. I use POP3 or IMAP. TFTP, Trivial File Transfer Protocol, used for remote configuration, upload or a backup of remote configuration files. We use TFTP. DHCP, Dynamic Host Configuration Protocol. So using that server, I can assign an IP address to the client PCs. For example, my laptop got an IP address from DHCP server. DNS. I open a website or I want to try to communicate my remote device using a name, but I don't know the IP address. So what is the DNS will give? DNS server. I send a request to the DNS. I ask DNS server, I want an IP address of google.com. I want an IP address of facebook.com. I want an IP address of youtube.com. So DNS server give the IP address of those. So then I can communicate with the devices with the IP address. Okay, given IP address of a domain or a host under domain to the client. Okay, NTP, Network Time Protocol, Kerberos, Authentication Protocol. It is LDAP is also authentication protocol. What is this NTP? Network Time Protocol. It sync the time as per your time zone from the time server. SNMP is used for monitoring purpose. Okay. SQL and other port numbers also there. For example, applications like SQL, Oracle DB, TNS Listener type of things. Tomcat applications also having a port numbers. What is the protocols and their port numbers also important, guys. Either first read it. If you cannot able to remember, by heart it. It is always useful if you know the port numbers of different protocols. Whereas 1,000 protocols or 1,023 protocols and port numbers are there. I listed only 10 to 15 only. Please read it, by heart it, or whatever you do it. Okay, that is the important one. Next one is OSA layers, open system interconnect. It is a kind of network model and reference model. It is. That's it. 5 minutes. Okay. What is the use of this OSA model? I can understand different types of network models like a TCP/IP model, IPX, SPX, or Apple Talk, different type of network models I can understand. I can create a network. I can troubleshoot the network related issues. It is a reference model. Just 7 layer, it contains a 7 layer and it is standardized by ISO, International Organization for Standardization. So 7 layers are there: application, presentation, session, transport, network, data link, and physical layer. The network, so guys, some people read from top to bottom, bottom to top. So with both ways are correct one only. If you are having an habituated to read the tell the layers from application to physical layer, do that one. If you are habituated to tell from physical layer to application layer, keep it that one only. Just understanding, do not interchange the layers. Okay. The physical layer, data link layer, network layer, these are all called a hardware layer or a bottom layers. The top layers are application layer, presentation layer, session layer, is called software layers. Okay. The transport layer is heart of OSA layer. It is also provide end-to-end connectivity. Application layer is all about your application and protocols. Like I'm using a web browser. It is a web client application. And there is a web server. Web server application is also there. So that is application layer comes into the server part and client part also. Application side. Web application, web server. Mail application, mail client. Okay. So sender receiver kind of stuff. Protocols, FTP, STP. So how do you access using the protocols only? That will be understand from the application layer. Presentation layer. What is this presentation layer? You're transmitting data, you're sending and receiving a data, right? So the data is in different formats. It's convert the data into ASCII format, then into binary format. Compress the data and decompress the data. So, and encryption, decryption also done in a presentation layer. Session layer. So when you are sending or receiving, okay, there is a session ID will be created. When you are sending a session ID, you are requesting or responding. Requesting or responding. In both the ways, session ID is there. So when you do requesting, for with the request, what are the information you are adding and sending? So it is goes with the session ID. And you're sending a request and you will receive a response till you completely receive a response. Like you download a file. After completion of file downloaded completely, the session ID will be terminate automatically. Till that time, session ID will be maintained. For example, I'm downloading a 2 GB file from the remote system. Okay, so I'm downloading a file. So as long as I'm downloading, as the thing is going on, the session ID will be maintained. The session should be maintained. Once it is completed, session is completed, so session will be terminated. I've opened a page. So I've opened some page. So it is request is sent, automatically data is pulled and sent. So it is still this request and response is happening. Okay. So once it is completely loaded, so it will shows the refresh button like this. It will shows. Okay. Refresh button. It means the session completely loaded and it is terminate automatically. If you click on something, if I click on something again, request will send. Okay. It is very important to know about a session layers. Okay. For example, I'm connecting with one network and I'm transferring data or loading a data from remotely. And I change my network automatically. I change my network automatically. The transmission kind of stuff is maybe interrupted. Okay, because of session layers. It is loaded. The session will be automatically disconnected. And it will be re-established. Some websites, what they will do, they do again and again. Yeah, session layer, presentation layer, application. Transport layer, what they will do, data, it provide end-to-end connectivity. It chop the data into small pieces called segmenting. It arrange the data into numbering and sequencing order. So what it will doing, it is doing error correction. Okay, so in TCP IP protocols are there, TCP type protocols, UDP type protocols are there. Like you take SMTP protocol, FTP protocol, SNMP protocol, these are a TCP type protocol. DHCP, DNS, TFTP protocols are UDP type protocols. What is the thing? The TCP type protocols, our behavior is acknowledgement based. UDP type protocols are not acknowledgement based. Okay, so that is the point here. Acknowledgement based, non-acknowledgement based. So here it is. What is acknowledgement based? So server send a packet to destination. Destination send acknowledgement for that packet. So source knows destination is received a packet. Okay, UDP source you send a packet, destination received it or not, source don't know because there is no acknowledgement. Example TFTP, you make a connectivity and you send a packet and you don't know whether destination received a packet or not. You are using SMTP protocol, you send a packet to destination, destination received, it returns an acknowledgement to you. If you don't receive an acknowledgement, you will send it again. That is called error correction. Okay, flow control, this kind of stuff it will do it. Okay, so this here is a TCP header is added to your packet data unit, so it become a segment. What is the segment? The segment contains about the numbering and sequencing order, flow control order, TCP UDP, multiplexing is inside your segment. The segment sent to the network layer. The network layer is added so source IP address and destination IP address to your segment. Then it is called a packet. And also it is includes the routing protocol information, means how to reach the destination information also included into this packet. Okay, this packet is sent to the data link layer. In data link layer, we have a two sub layers called LLC and MAC layer. If in case you are connected to the WAN connectivity, WAN related protocols is that information is going to be added like a PPP, SDLC, frame relay, MPLS kind of stuff. Otherwise, it is only MAC address kind of stuff only will be added to your packet called source MAC address, destination MAC address is adding to your packet plus CRC as a data tile. CRC means cyclic redundancy check used for error checking. What is use of CRC? When destination received a packet, it verifies the packet with CRC. CRC has some number from your data. It is a kind of algorithm. It verifies your data if data is good or corrupted data. If it is a corrupted, drop the packet. So it's checking. Error checking happens at data link layer. Error correction is happened at transport layer. Physical layer depends upon your physical connectivities. You are connecting one device to another device. So how you are connecting is wired connectivity, wireless connectivity, or Wi-Fi type of connectivities. So you are using Ethernet type of communication, Ethernet, fast Ethernet, Gigabit Ethernet, UTP, STP, electrical type of signals it is. Okay. Wi-Fi type of connectivities, wireless type of connectivities, right? So radio signal we are using 2.4 gigahertz, 5 gigahertz type of frequencies we are using. Fiber optical type of connectivities, light waves is a mainly signal. It converts as per you for physical connectivities. That the frame, what is the frame? Source MAC address, destination MAC address, packet information, and CRC, cyclic redundancy check related information we are added together, become a frame. That frame is converted into bit stream in the physical layer. Okay, the bit stream again convert into electrical signal and radio signal, light wave signal based on the what media you are using. Guys, when you are sending and there is a destination which is receiving. When you are sending, we use first one is application, presentation, session, transport, network, data link, and physical layer. When you are receiving, physical layer, data link layer, network, transport, session, presentation, and application. Right. Okay. And what type of protocol we are using? We are using a TCP/IP protocol suite. TCP/IP protocol suite. So OSI layers and TCP/IP protocol suite, there is a comparison. In TCP/IP, only 4 layers. If you are comparing, the TCP/IP application layer is equivalent to the OSI layer, application, presentation, session layer. So one layer is doing all 3 layers work. And TCP/IP transport is same as a OSI layer transport. TCP/IP internet layer is network layer in OSI model. TCP/IP network access layer is data link or physical layer, data link and physical layer combination. So that's why it is net NIC's LAN cards comes under network access layer under TCP/IP. We are using TCP/IP model network communication. Okay. So I have written some of the protocols, commands directly here. Okay. So IP config is used to find an IP address. It shows IP address, subnet mask, default gateway only. IP config space /all will display IP address, subnet mask, default gateway, lease duration from if it is from DHCP server and the DHCP server address and DNS server address and MAC address also. Get MAC only shows the MAC address. ARPA that shows IP address, remote machine, IP address and MAC address. Other machines, not our machines. Our machine also you can get it. What is a ping? Ping command is used to test to make sure that you are able to communicate from source to destination. Okay, test the connectivity. Ping command is used for testing the connectivity. Trace RT, it will tell you how you reach the destination. For example, ping www.google.com. Ping space www.google.com. Can I reach to google.com or not? Trace RT www.google.com. How I reach google.com? Which routers I cross to reach the destination? IP config space /release. It means your device is configured with an IP address dynamically and you want to remove it and get it new one. So you want to flush the current configuration IP address, dynamical IP address configuration, you want to remove it or flush it. So use IP config space /release. IP config space /renew. So again, you want to get an IP address from DHCP server, you want to use it. Other kind of stuff is also like display DNS and all. Okay, that's it. Okay, so this is your both hardware and networking. From networking, so I didn't record a few points, guys. So maybe in the next class, if you have any doubts, I already sent this link. Please go through the link. If you have any doubts in the networking also, we can discuss. Okay. Next one, we can go through directly what is the different type of servers and what are the different type of services we are getting from the servers. Then we'll go to Active Directory, work group domain, DHCP, and then virtualization, cloud computing. One by one, we'll go. So do not worry whether which batch you are belongs to. I'm try to commonize to everyone. Okay. So I will complete all your topics as perfect. Okay. Okay, guys.
Okay, sir.
Sir, share this document in the group, sir.
Already group. Okay, I will share it.
Yeah,
Definitely.
please share.
I'll share into all 3 groups. Okay.
Okay, please share the documents and recordings also, sir.
Recording also I will share it. The recordings you should access to YouTube. I will
Okay.
share the links, recording links also. Okay.
Okay. Thank you, sir.
So many links. This is batch 4. Okay. Batch 3 already having this link, but I'm sending again. Who is that? Means if anybody other than batch 4 and batch 3 is like Noida batch people, put a share link message on the group so I can understand. Because I'm seeing a lot of batches here. I don't know which batch it is. This is Madhu sir batch, I think.
Yes, sir. This is more advice.
Okay, so very good. So I will confirm this. M2 is also here. So I got it. Okay. Okay, so here it is. Okay,
Okay,
the
sir.
notes
Okay.
is contains other notes if possible. I will share it. The complete notes is also there for different batches.
Okay.
Okay, currently it is just a link. You can download the notes to you once we are completed it. Okay, yeah, that's it for today, guys. I'm going to stop the recording. In case of